Welcome to Lightning Talk number 3. This is Daniel Moore and Justin James from the iRODS Consortium. They have made a thing and they're going to talk about it. Parallel transfer between the Python client and S3 storage. Go for it.
Two great technologies that taste great together. What we'll be demonstrating, and it's taken just a couple of minor tweaks. Those are temporary. The story on that will probably unfold in a little bit. So I'll present a couple of these slides, and then we'll transfer over to Justin for the discussion of the particular tweaks that went on between our bits of the puzzle. And so what we're really showing, what we're demonstrating with this is two technologies. One is probably already very familiar to people. It's the ability that iRODS has through a plugin interface to abstract arbitrary storage technologies so that they look the same. That's the tendency. So we'll be transferring data essentially from a client, the PRC, which has implemented parallel transfer capability, put and get, to and from the S3 bucket that is mounted, or that is in the logical file system, represented by iRODS in the file system. So just a brief discussion of this is a multi-connect thing that's controlled by the client, as I alluded to in my previous PRC talk. It'll basically be multiple connections handled one per thread from the client. The advantage is you won't need the high ports and all the extra complications that come with it. You can reuse login information and context so that everything is pretty seamless that way. And then let's see. Right, the tweaks had mostly to do with the fact we needed information in the multi-process and multi-thread end on the client and multi-process end on the server plugin side to agree. We needed information to agree between the two. In the end, we may have, especially with the move to the cloud that I think people are thinking about now, incipiently, there will be probably a prepare to receive call for both server and client endpoints. So that will help us agree on the number of threads and other information that we may need to do the transfer. So I'll unshare now and let Justin share.
Actually, go to the next slide and I'll talk about it.
Okay, all right.
Okay, and then I'll share a screen. Okay, so basically some of the challenges that we had to deal with when doing this, basically the S3 should work with both the new style of transfer and the old style of transfer. It wasn't a challenge. The port part is kind of hidden from the S3, from the plugins, so that really wasn't a challenge itself. The biggest challenge was that it's using multi-process rather than multi-thread, and what that did was it made us we had to use shared memory for coordination, because the threads and or processes have to kind of coordinate when they're, especially in a multi-part upload, they have to kind of coordinate timing and stuff. One process has to begin the multi-part upload, then all of them will do one or more parts each, and then finally the last one to close has to do a complete multi-part upload. So there's some processing that's required there. There's a little bit of shared memory, like the e-tags vector, which you get back for each part. The final complete multi-part has to send all those e-tags. Stuff like that had to be in shared memory now that we're doing multi-process instead of multi-thread. That kind of made me a little nervous at first, because when you have shared memory, then you have something a state that's maintained across multiple transactions. And so we had to add a failure recovery mechanism with a shared memory timeout, so that in case something went wrong, something crashed or something, that we could recover from it. And good and bad, the shared memory timeout and recovery was tested pretty thoroughly in development because things sometimes crash in development. Okay, and if I can share now.
Yes, just a second. Okay.
Okay, and I'm gonna hop to a different screen to actually do the typing. Okay, so I'm gonna just real quick demonstrate a parallel put using the new Python with the parallel transfer engine to an S3 resource. First, I'm gonna put with iPut just so we can kind of compare. You guys are seeing at the bottom of my screen, correct?
It's a little small. I don't know if you can make it a little bigger. Maybe not. It's fine.
If it's okay, I'm just gonna leave it.
Okay.
Okay, so we did a put and we had one process ID. So if you looked in the logs more, I had logging turned up pretty high. You'll see multiple threads doing the parallel put. Okay. Now we're doing the put. Oh, let me show it to you real fast. Okay, this is the Python script we are doing to do a put. We're also writing to the Amazon resource. Sure. Okay. And if you look at the number of processes, there was actually 3 different processes that did the put. And I don't have a get.py, so I'm just going to get it with just with the iGet. And so I put the large file using the Python parallel transfer engine and then got it back as large file 2. And as you can see, it has the same checksum. And that's it. Just kind of show you how it works. It was a little bit of a challenge to make this work. When I found out that these were going to be doing multiple processes, then it kind of complicated things a little bit, but it's working now. And that's all.
Very good. It's pretty cool. First implementation plus a tweak. So that means that the model holds. Very good. I didn't see. Did we see questions? Let me see.
I think it's, if I can jump in for a hot second, I think it's important to reiterate that there is going to be a contract around this behavior because we need to maintain, semantics and behavior from the client side plumbed all the way through to any storage on the back end. And so, as Dan said, there's going to be a prepare to receive where decisions can be made, and then the client's going to have to abide by those decisions.
Yes, and in the meantime, before, since we don't have that prepared to receive, we expect the S3 plugin expects the client to work in a specific manner that kind of mimics what iPut does.
Sure, which we can document and communicate. Yeah.
Yes, it is in the slides, but yes.
Okay, very good. Thank you.
And then I think we had a question from Pete. Pete, I'm gonna make you ask your question. Let's see. There you go. Can you ask your question?
Yeah, I think it may have been answered. But I'm interested in the idea of being able to slice within an object. So a common challenge in bioinformatics is you've got, say, 200,000 genomes of interest. You're looking maybe at a file that's 150 gigabytes in size for each of those samples, but you're only really interested in a 2 meg slice through the middle. So the question was, will we be able to seek within those objects and just extract the 2 meg section of interest to compare and contrast rather than get the whole object?
You can do it. Well, if you're just doing a get and you're opening a read-only mode, you should be able to do it no problem. It will go out and get what you asked for after the seek. If you open it in read-write mode, it's going to force it to use a cache file.
That's great. I think get's our main use purpose for that. So that's fantastic. Thank you.
Sure.
Very good. Thank you.